Hello, a very good friend of mine asked me to share my own experience of how to develop and publish web applications with containers. And the main question was if it's possible to publish app for free for some limited resources or limited amount of time. So here I am, and Женя, это демка специально для тебя. Let's go, ушки. So first of all, let's check our agenda. We will develop and build a simple to-do application. As a first step, I will show my current environment. For development, for local development, I'm going to use Docker desktop. Right now my Docker desktop doesn't have any containers, doesn't have any images, and doesn't have any volumes. It's absolutely empty. Also, during the demo, we will use a Postgres database hosted on Elephant SQL. Let me find Elephant SQL, pretty amazing database hosting service with a free tier. In advance, I've created my simple demo database on a free tier. Works nice. Also, we will use Redis database for our cache. Redis cache database hosted on the Redis.com, and I also created on a free tier, pretty small, my own database. Next, we will host our application on Azure, and this is my Azure. It's pretty empty for now. And for container images hosting, we will use Docker Hub. Here is my Docker Hub with some containers previously published, but we will republish everything from scratch. Now let's check what we are going to build. It will be a simple to-do application. Basically, it will be a web API built with a .NET, and it will be React.js front end built with a JavaScript. Our front end is going to talk with our web API. It's two absolutely separate web applications. First one created with a Create React app. It might be absolutely any front end app, Angular, any other framework, plain JavaScript, whatever. It should be possible to host this one as a web app with Nginx. And our web API is built with a .NET. It might be absolutely any web API application built with a Golang, with a Node.js, with absolutely anything. For the local development, we will host our Redis cache database inside Docker desktop. Our Postgres database also will be published in the local Docker desktop, together with some set of scripts which allow us to do a little piece of magic. Okay, so let's explore our app. So our API is built on a local computer with an environment inside the Docker desktop. Now it's time to show code in the Visual Studio. Here is our API. It's pretty simple web API which operates with a single entity called to-do item, which has ID, name, and day, of course, as a string. Okay, so we are going to host to store this to-do item in the database context using entity framework core. Then all these entities will be exposed as endpoints via web API behind the tasks URI. Here, mapping for our endpoints. This is endpoint to create new task. For that, we just use entity framework database context to save new to the item. When we get list of all tasks with a pagination, we first of all check if we already have requested data in cache, and if we do not have in cache, we go for the data to the database. The same for get single task item. We check cache. If it's not on cache, we get data from the database. Then put to manipulate our task, delete to remove task from the database and from the cache as well. So this is our local web API, pretty simple one. It has Docker support in it under the hood. So this is Docker file, basically the standard one added by the Visual Studio with a create add Docker support our web API. And what is more important, it has Docker Compose, where we define our services, one of which is our task API built from the Docker file, together with infrastructure with the two databases, tasks database, which is Postgres latest, and cache, which is Redis latest. From the connection point of view, during the development time, we have two connection strings. First one to the Postgres, local Postgres, second one to the local Redis. Okay, let's start this project for the local development. So here I choose start Docker Compose and run my composition. Let's wait for it to be started. Okay, good. This is our local instance of the web API with a Swagger UI in it. If we check our Docker desktop, what we can see here is our Postgres database up and running. We have our Redis cache database up and running, and we have our web API service started and exposed port 5000. Here is Swagger. What we can do is get some data from the database. Currently we have nothing, so let's create new task. And if we try to get list of tasks once again, we have our very own little single task in the local database right here in the Docker container database. The same for the read operation. When we try to get first task, we'll receive our task, first one from the database, second time from the cache. Works as a charm. Let's check what's next. We have our local containers created by the Docker Compose. Here they are. That's awesome. Now let's check what we have on our front-end side. So we have right here, it was web API, and we have front-end web application built with a React.js. Here is a source code. It's just a simple web application with a React 18 created with a create React app, with a couple scripts in it, with some components, and with a pretty simple code. What we can do is to run this app locally. Our front-end application connected with our backend via HTTP URI in order to get data from the databases. So in order to start front-end, first of all, backend web API should be started on the local system. Here is our local Swagger. Now in the environment variable file we have a setting which points us to the web API. Here's URI, everything's configured correctly for the local development, and what we can do is to start local development of the front end app. And boom, this is our front end connected to the local instance of the web API. That's really good. What we can do is to try to create new item in our database from the UI. So it will be task from UI on local. Good. We have front end and backend started locally. So our front end and backend started locally inside the Docker desktop. This is our composition. It's pretty simple, pretty easy to develop, and host absolutely anything with a Docker desktop and run and debug and do absolutely everything what developers love to do. Okay, let's check what next on our agenda. When we are happy with all the development routine, what we can do is just to do a little step forward in order to create containers to be ready for the publishing on the remote hosts. So let me close all the running services here. Okay, and also I will delete my composition from the Docker desktop. So everything is stopped right now. Okay, so let's build our containers for the backend. So we have a Docker file in the backend. This one created by the Visual Studio with a multi-stage build where we create base image, then from the base we create build image and do build operations, and after that we create publish image and just copy published assets to the final container, and then we run this final container. So what we can do is we can build this container for the future publishment. So we need to do this from the to-do folder, probably from here. Yeah. And in order to publish container, we execute in order to build container, we execute docker build with the Docker file, and we give a name to the container. Let's wait for it to be built. Good. Inside my Docker desktop, I have my new, the name was that one. I have my new container. Oh, sorry, new image, not container yet, it's an image. Good. Let's run this container from the Docker desktop. So we run this container and expose port for external access. So here is our container. Now it's up and running. What we can do is go to Swagger, check what we have inside the databases, and for now we have, let me check configuration, we have production build, and during production, and we'll build container here. When we build container, we set the configuration release, and for the release and for the production environment, we set connection string to the prod, this one. So if I try to get data from the this instance, yep, I see different tasks from the previous run because database were used a little bit for the demo preparation. So this data is from our prod database. So what we did with our build script, we created image, and then we started image with a configuration to be pointed to the production. That's good. Let's see what we can do for our front end. Basically the same. We have a Docker file for our front end, and as soon as this is React.js application, we build our React.js with a command file inside the first stage of our build process. And as a second step, with our multi-stage build for the front end, we create a image with Nginx server. We copy our outgoing assets from the previous step, and we also copy a web server, in this case Nginx configuration file. This is pretty standard configuration file to host static assets on port 80. Okay, so let's try to build our front end. Good. Front-end image is ready. Here it is. To do up. What we can do is to run our container with front-end. In the Docker desktop, all our containers, we have another one to do up. Let's see what's in it. Okay. Let's see what the problem is. And the problem that right now this front end points to the development backend. Let me remind that right now backend is hosted in the same way like it will be hosted in the production. So in order to fix this problem with environment, of course it should be used like environment variables or some kind of configuration, but I'm lazy. And what I'm going to do, I'm going to change URI in the env file, then rebuild image, and restart front end from the updated image. Let's see. Okay, right now our front end started from the container in the local desktop environment, pointing to the local web API, started also from the container. So let's add task from container on local. Good. We have couple tasks created in the local API, which points. So another one application created from the image, which points to the backend, which then connected to the production database. Good. We're happy with testing our composition with manual up and running on the local environment. And what we can do is then publish two of our images, these two images, to the Docker Hub, for example. So we have two images and let's publish them to Docker Hub. In order to publish, we need to be logged in, and I already logged in as my Docker Hub account. And what we need to do is to push Web API first. And push Web Application or UI second. Good. So right now in the Docker Hub, we have two images published just now. Demo to do API and demo to do app. Okay, so right now, results of our work published to Docker Hub. What for? It's easy because from the Docker Hub, we can create web applications anywhere, including Azure AppServices from a Docker Hub containers, AWS container service published from anywhere. We could publish on a DigitalOcean, on the Fly.io, absolutely everywhere. So the whole point of having containers published in the Docker Hub. Let's first of all kill all of our previous work on the local Docker desktop, basically because we don't need it. So I just remove everything. I easily can start absolutely everything from scratch. I will also remove images, basically I don't need them, and volumes as well. So right now my Docker desktop is cleaned and two container images published to the Docker Hub. Good. Let's switch to Azure, where we create two app services as a free tier from our container images. Let's close these leftovers and go to Azure. So what we need to do first is to create our resource group. Somewhere in West Europe. Good. Then we need to create Web API app service. App services. Create new resource group, the one we just created. App service name, I already chose one. Publish from the Docker containers with a Linux in the West Europe. We can create new Linux plan, but I already have one on a free tier and not going to pay anything for hosting here. We don't need any databases, but in the Docker we need to select that it will publish single container from the Docker Hub, and the container name is exactly this one. Exactly this one. Demo to do API. Good. Public container name. Don't need startup command because everything already there. And create. Let's wait for our web API to be created on Azure. Our resource is ready. What we need to do is to do some configuration in the configuration settings. So let's go to our app service configuration and add a couple things here in order to map ports. Save. And restart our app service. In the deployment center, in the logs section, we can see logs from the deployment process. So let's see what's here. Here are our deployment logs. So we pull image from the Docker Hub. Everything is good. Then we started our application from the container image. Let's try to open its local Swagger. Beautiful. We have Web API deployed to Azure. If we get list of all tasks, we can see that Azure API connected to the production database. So our to-do image from the Docker Hub deployed to Azure App Service. Good. Let's deploy frontend to Azure. For that, we create another one, App Service, right here. Create web app. In the newly created resource group, web app name, to do app, Docker container, Linux, somewhere in Europe, in the my free tier with a Linux plan. Next. Don't need database. Single container from the Docker Hub, public. And image we're going to be using here is our second image with a front end to do app with no startup command. Okay. Let's wait for the resource to be ready. Okay, let's go to our resource and open its front-end page. Here is our front-end, and of course it doesn't work because I'm lazy and I did not set correct API URI to work with tasks. Once again, I'm lazy, and instead of as it should be defined in the configuration, what I'm going to do, I'm going to hardcode URI in the env file, rebuild container, republish container to the Docker Hub, and next time when I start my Azure App Service, it will pick up latest container from the Docker Hub, this time with correct backend URI. So let's verify that it's been restarted in the logs. We can see that this was the first time we pull image, and this is second time when we pull updated image. If we refresh our front end, we will refresh our front end. Not yet. We will see that our front end connected with the Azure Web API backend and gets its list of tasks from the production Azure. Basically, that's it. We can create need to find out how to spell, and we can create new task right now on the Azure. What's in our agenda? We rebuild our UI with a correct URI and enjoy our production app. Basically, that's it. Good luck with containers.